Now let us understand how to tidy the data. Let us see some of the variants that we might encounter while making our data clean or tidying the data. So here you can see this format is not in a structure that can be used for proper analysis. Here you can see some of the attributes are given into the rows, and you can see this is 2012. This is the observation that should be, but it is given into the columns. So rather than having these years value, you can see 2012 is a year, 2013 is another year, 2014 is another year. What if we have multiple years? Then for those years we might have to maintain separate column for each of the years. So that is a huge task. Maybe using our data to be stored in this format, and what if we have a big data that is going to be repeatedly changing, because the rate at which the data will be produced will be increased at every year. So now using this format will be very much hard, because for each year we are maintaining separate column or separate attributes. So rather than doing this, what if we maintain a separate column with a name variable as year and store all the years to it? See here, 2012 has been made as an observation now. 2013 has been made as an observation. 2014 has been made as an observation for each of these rows. So this is what we need to do. So basically creating observation in terms of row, rather than doing it, what you can do is having the separate column for each of these observation. It might not be fruitful. So rather than doing this way, you can create a separate variable where you can store these attributes, and for each of these attributes you insert a different observation. So just maintaining a different column is harder than maintaining a separate rows. So what we have done here is, in this case we had to maintain a separate column for each years. Now we don't have that. We have a single year variable, and now we have to maintain the observation for each variable. So that is what we have done here. In this case you can see we have only two observations. First one is this school name and its observation. Second is this school name and its observation. Now this same observation has been converted into multiple rows, but now we no longer have multiple columns. So each of these years has not been transformed or created as a column. Rather we have a separate variable where we can store all of these years at once. Next, doing this, what we can have is, we can have something that is a better performance in terms of analysis. So this is my actual data. See here. Now I transform this data into something with this year transformed right here, and the quarter is the information related to this Q1, that is committee Q1, and this quarter information about each of these categories. Now after I transform this data into this one, I can have a better performance during the analysis. I can just say what is the comedy movie that has been made in 2014 and what are the total number of hits. Then I can clearly see quarter Q1 year was 2014 and the category was comedy. So that means I have 2 hits at that position of this category. And if you do the same interpretation here, it is quite harder because this is not an elaborative way. So basically converting this into this format, we have an elaborated information. Quite clear description of the information can be seen here. Similarly, you can see the messy data over here. Very messy data like variables in the both columns. See here, this information like these ratings like excellent, good, these categorical variables has been created right here. So rather than encoding this way, we made a separate column for each of these categories. So excellent should be made one and good is made another column. Now if the movie is excellent, then we give the value 1. If the movie is good, we give the value to that attribute to the good. So in this way, we can transform this table into this one and we can have a better interpretation now. Similarly, these tables have duplicated values. See here, the same person, Jim Jones, his cell and totals has been repeated twice, and from here also Mike Jekyll has the 2 times information that has been right here. So if you find this type of information that has been duplicated, then what you can do is you can follow the process of normalization. You can create separate value for them. So duplicated value will have a separate table and non-duplicated value will have the separate table. Now in the separate table that has been made of a duplicated, we only have a unique key now. See here, so Jim Jones has been repeated twice. We only keep 1 observation for it. Mike Jekyll has 2 observations that has been repeated. So we will remove 1 of its observation and keep only 1 over here in the new table. So if you have a duplication in your data sets, use a concept of normalization to avoid duplication. Normalization means breaking down into multiple tables. So we create here multiple tables. Similarly, what if you have multiple tables divided with the same attributes? See here, I have table that are 3 tables, same category, same quarter name, same year and same hits. Then I can combine all of these into one big table accommodating varying format. So you can see category, all the category has been assigned here, quarter, all the quarters has been assigned here, all the years value is assigned here, and hits has been assigned here because I have 3, that is deck of these tables, and I assigned all of them into one single big table. Now we have many popular open source options in order to facilitate data pre-processing steps. There is RStudio and R programming. We can use this. If you are using Python, then we can use IPython notebook and Pandas library for data munging steps, or you can also use data science toolkit. Similarly, this is the process you can use in order to convert the raw data into some meaningful information. We can use Beautiful Soup, which can be used for web scraping. You can use the TextRact, you can use Tesseract, you can use OCR Feeder. So these are some of the tools that you can use in order to convert the raw data into some meaningful information. Similarly, we have commercial vendors, Platfora, we have Trifacta, DataWatch, all of these are commercial vendors for data munging. Similarly, if you want the hands-on data wrangling steps, we have further incoming videos where we are going to implement these type of techniques by using practical, that is concepts. And we have here, that is the CSV format, PDF format, we have API JSON format, and this is the data ingestion. So that means we might have the data in this format. Maybe we can have the data in CSV format. Maybe we can have the data in PDF format. So after having this format of data, we need to clean that data. Maybe we need to handle missing values. We need to check if the format is correct or not. We have to just handle the outliers, whether to keep it or remove it. We need to have certain criteria related to data errors per domain. So we need to specify how much data we can have within our, that is data errors. So this is based on the business need. So if our business need permits the data that must be valid, then we need to pre-process our data in a way to make our data validated. And similarly, we can augment your data. Augmentation means aggregating our data sources. That means taking data from multiple sources so that we can have a bigger picture of a data. So finally, why should we care about data wrangling or data munging steps? First of all, you can see the blooming that is job website or a job trend that is related to data scientist and data wrangling process. You can see this one. So it was close to like, that is like 500 people, that's like in a population demand rate, but now it has been going in a so much faster rate that this is the one of the hottest job trending at the current season or at this current time. Now, why should we care about data munging steps during data science project is that we can have a better outcome or better accuracy of the model if you perform data munging or data pre-processing step. Next is you can have a tooling innovation. You can find something unusual from the data so that you can use them as a pattern for your machine learning product. You can also increase productivity. You can ease of use because the data will be simpler, and if the data is simple, you can use it directly, you can access them, you can slice and dice your data, because after the data munging step your data will be into some format which will be easy to access. Next is lessened skill gap. So you don't have to basically need a lot of concepts in order to perform data wrangling steps, rather than having some concept like how to clean a data, how to verify a data, how to maintain a data quality steps, like the topics that we discussed previously, like validating data, checking the accuracy of a data, checking the consistency of a data, checking the uniformity of data. If you have those knowledge, then it will be enough. And it is a great skill to have as per Indeed.com. And this is the data that I have just taken out from the Indeed.com website, and it is the great skill to have as a data scientist. So this is important thing to have, which is a data wrangling step, and we are going to discuss about it further by creating some code, and how to clean those data will be seen in the upcoming videos.